So welcome, Lorian Dawson and Heather and Nicole, and connecting to it says. This is the Mike. This is the week 8 webinar for the Prep Stats class, and hopefully everything is going well. I want to share my desktop and I'll show you what we're doing. Okay, so it turns out this week is actually pretty packed with material, but there's no test or anything like that. It's just regular homework. So I figured I'd just go over each of the assignments. And I even thought, I haven't done this before in this class, but I thought maybe I'd even jump right into the homework. So you can see what the homework looks like and be able to do it. Because there's some people have trouble with it, but there's a lot of word problems. And some people have issues with word problems, but there's going to be word problems. And we're going to start out with evaluating algebraic expressions, okay, which is a fancy word for word problems, because it's not just to evaluate an algebraic expression, but evaluate algebraic expression with those variables, and then what the variables represent are given in a paragraph. And then we'll get into operations with inequalities that come from word problems. Then we're going to get into order of operations that come from word problems. Okay, and then finally, we'll get into summation notation. That's not all word problems, actually. That's the one piece that's not. But for some people, it looks a little weird. You may or may not have seen it before. So this is one of those that may not be a review. This may be new math, or it might be review. That is that's a plan for today. I want to mention one more thing, and that is, I don't know if you noticed, but the schedule came out for summer and fall. And so you can, register for classes now. So you might want to think about that. I do recommend not waiting too long. Don't wait a year to take stats after finishing this class, because then this class won't be that worthy at all, because a year is a long time and you'll forget everything. Wait until fall is fine, but I wouldn't wait until next spring or something like that, because I think that's a big mistake. So you're better off taking it in the fall. Summer, be careful. If you take it in the summer, note that the summer class is a 6-week class, 5 units each, 5 units to the class. And that equates to 30 hours a week of work. Okay, it's over in 6 weeks, but it's a lot of work. In fall, it's 15 hours of work a week, and that's a little more doable. Okay, and those are averages. Some people work more, some people work less. But just a couple notes, since again, this is prep for stats, and the stats classes are now publicly available to take a look. Also, if you're going to take an online class in stats, definitely register early. Don't wait too long, because the online classes fill up quickly. If you're going to take a Eve class, which is a little different than online class, then they fill up a little later, but they could fill up. You never know. And Eve in the fall next quarter will be still online, but it's Tahoe only students basically, and there are people who are set for a specific time period, whereas the true online classes don't have a scheduled time period where you have to be. Like this is a true online class. So you'll notice that my webinars sometimes are Mondays, sometimes they're Tuesdays. I vary them because I don't want to set a specific time, because then I could zap you if you could never make that time. So anyhow, that is just the announcement about the fall. And I know this is the prep for stats, but I want to advertise out that all classes are open, not just stats. So take a look at the full schedule and make sure you balance your schedule. Any questions about anything? Any questions? Any questions? This is a great time to ask questions if you have them. Okay, if there's no questions, I think I'll get to talking about new material. And that is, I'm going to start out with evaluating algebraic expressions. And as I mentioned, what I'm going to do is I'm going to go to the homework itself, and that way you'll see it. Oh, one more thing I don't want to forget, and that is I created your final exam yesterday. Okay, actually, was it yesterday? Day before yesterday. So, and it's a little longer than the midterm in terms of problems, but was length a problem for y'all? Did you run out of time? Speak now or forever hold your peace. So was it a test that you ran out of time? Okay, so it's going to be a few more problems than the first exam, but not that many. It's still in the 20s. But it's a few more problems because what I did is, unlike the first exam where I picked 2 problems from each section, for the final, I picked 1 problem for every section. And so every section is represented exactly once. So that's the idea. But it was a little bit longer than the midterm. So I wanted to make sure most of you seem like that's okay. Okay, so since there were no objections, it's going to stay around that way. Okay, the good thing about it being a little longer is that if you make a mistake, if you get one of them wrong, you don't get docked much because it's 1 over however many questions there are. So it's 1 over 27 instead of 1 over 22 in terms of your lost points. Okay. All right. Now let me go and I'm going to just open up the evaluate algebraic expressions. And this is your homework. I haven't done this with you guys before, but I thought this might be a good week to do this since there's so many different kinds of, there's 4 different assignments due. All right, so I'm not going to pick question 1. I want to go out a bit. I'll let you pick. Pick a number between 5 and 11. 6 it is. Okay, so I'm going to do a few of these. Like I said, we have 4 sections to cover, but I figured I'd get this set for y'all. Okay, so we're going to calculate the mean and standard deviation for the following set of sample data by hand. Okay, and as we're getting closer and closer to the statistics class, I'm going to spend a little bit of time talking about what these things are. Okay, you might have heard the word mean before, you might not have. Anyone heard the word mean before? You know what that represents? In a simple word, if you had to talk to an 8th grader. Yeah, so the word mean, the simpler word for mean is average, but in statistics, we call it the mean. Okay, not because it's just evil and mean and stuff, but just what it's called. So that's why it says calculate the mean, which means add the numbers and divide by 5. So this shouldn't be too bad. So let's see if you can do that. You can use a calculator, you can do it in your head, whatever you want. I'll do it in my head too. And by the way, I want to warn you, when you do your problem, it won't be these numbers. So don't just assume that you can write down the answer to what I get on your problem because it'll have different numbers. The numbers are all randomized. Oh, good, good. Okay, at least a couple of you got it. So let's see. I like to do it the easy way. You can add them however you want. 6 plus 4 is 10. 3 plus 7 is 10 more, that's 20. Another 5 is 25. 25 divided by 5 is 5. Any questions on part A? Okay, now comes part B. And again, what I'm doing is I'm doing more than what the problem states. I'm going to get you more ready for statistics than this tells you. Okay, I want to talk about why it is what it is. All right, so the first thing is if you look at x minus x bar is a symbol for what's called the sample mean, so the mean of the sample. The x are the values. So if you take If you subtract two numbers, what are you finding? Just kind of in words, in terms of geometry. When you subtract two numbers, what are you finding in words? Yeah, you're finding the distance between the two of them, okay? But kind of, because you could get a negative number or a positive number. So it's like a distance. It's sometimes called a signed distance. So let's do that and find those distances. So if we take x minus x bar, well, the x is 3. And if I subtract x bar, what do I get? What's x minus x bar in this case? Yeah, -2. 3 minus 5 is -2. And now we do it for all the rest. What's 4 minus 5? It's not a trick question. Yeah, -1. 6 minus 5 is 1. 5 minus 5, I hope you can all do that in your sleep, is 0. 7 minus 5 is 2. Any questions so far? All right, well, it turns out that with the standard deviation, you don't really want to do the subtraction only because then you get negative numbers. And what you want to do is you want to say, well, if you're on the left or the right, you're still far away from it. Do you see that? So by squaring it, hopefully you know that when you square something, the negative goes away. So that's the reason why this is a square. So again, I'm doing more than what it asks you to do because I want to prep you even more for stats. So let's square it. And again, you can ignore the negative signs. 2 squared is 4. 1 squared is 1. 1 squared again is 1. 0 squared is 0, and 2 squared is 4. That was too fast, let me know. But I'm hoping that you can do 2 times 2 really fast. Any questions on that? Okay, then it asks us for total. So what are we supposed to do with all these numbers? Yeah, we're supposed to add them up. 4 plus 1 plus 1 plus 4. There's a plus 0 too, but you don't need it. What do you get? Yeah, 10. Any questions on that so far? Okay, then it says calculate the standard deviation. And it says the standard deviation, S. S is the letter used for standard deviation. It's the first letter of standard deviation for a sample. Is the square root. And then it says sigma. This thing is sigma, by the way. Capital sigma means sum. Of the sum of x minus x bar squared divided by n minus 1. So we need to do that. Okay, I think that's maybe the hardest part about this is how do you read that? So first thing, what is the sum of x minus x bar squared? The hint is we already know. Yeah, that was a 10. Sum and total mean the same thing. So there's a 10 there. What's n minus 1? So what's n minus 1 here? Anyone know what that is? Okay, so n represents how many items there were in your sample, sometimes called the sample size. So how many items, what is n first? Yeah, n is 5 because there was a 3, 4, 6, 5, and 7. There's 5 of those numbers. So I hope you can all do n minus 1, which is? Yeah, 4. Okay, that's something I expect you all to be able to take 5 minus 1 without a calculator. So that means we're supposed to divide the 10 by the 4, and then we're supposed to take the square root. Okay, that's not going to be such a nice number. So that one you need a calculator. And I'm going to go SQRT, parentheses, and the parentheses are really important, 10 divided by 4. And what we get is 1.581138830008. I guess you can. I don't think it tells you. It probably should. I should probably fix that if I can, if I'm allowed to. Does it say how many decimal places? It doesn't. So I'm going to copy and paste it in. More decimal places than you'd ever want it to be. Okay, just a note, what does this mean? Well, what we just did, basically the square and the square root kind of cancel. So what we're kind of doing is we're adding up these differences and then divide and ignoring the negative sign and dividing by how many numbers there were. So what this says is a standard deviation gives you kind of an average distance from the mean or the average. Okay, are things really spread out, and by average being very far away from each other, or are they not so spread out and they're close to each other? Okay, and what we found is that kind of an average distance is around 1.6. Any questions on that? And notice the mean is 5, and that makes sense because we got a 0 distance. In fact, these are the numbers. We got a couple 1s and a couple 2s, so 1.6 sounds about right. Anyone lost on what I'm talking about? Anyone lost? Okay, you want another one like that, but then we don't have time to do the other sections. That's the problem with that. Okay, if there's a step in it that you want to see again, I can do that. But if I do the whole thing, we've already spent like 15 minutes. So is there a step that was a little hard for you? So again, the X bar was 5 because we added them up and divided by 5 and got 5. Then we subtracted 5 from each of these numbers, 3 minus 5, 4 minus 5. If I have time, I'll do one at the end. How's that? And remind me. Any questions? Because I want to do enough types. Okay, so let us, again, I don't need to submit or anything, but let's go, why don't we grab another problem? Let's hope that's real different. Good. Okay. So suppose that the age of a child, sorry about that. Suppose that the age a child first learns to walk is represented by a random variable x, which is uniformly distributed between 9.1 and 13 months. Okay, kind of seen as uniform distributed kind of thing because there's a whole chapter on it. Find the probability that a randomly selected person learned to walk older than 11.6 months. So here's a picture. And by the way, 9.1 is the far left point. 13 is the far right point, and 11.6 is this one that's not quite in the middle. Okay, so first thing it says, find the height of a rectangle. And it says that the area is a base times height. We've actually talked about that before. And notice that the base is going to be the 13 minus 9.1 times the height is equal to 1. So 1 over 13 minus 9.1, that's where that came from. So let's see if you can do that in your calculator. So I want to make sure that you know how to do order of operations correctly. See if you can do that, and I'll do it in my head. Let's see what you get. Put in your chat box what you get. Rounded 4 decimal places they want. So 0.2564. Okay. So I'm going to go 4 decimal places. 25564. Uh-oh. Maybe I better do it. I can't do that many decimals in my head. I can do 2. Let's see what we all get. All right, maybe I'll do it. 1 over 13 minus 9.1. So 1 over parentheses 13 minus 9.1, end the parentheses. 0.25641. So 0.2564. Any questions on that? Okay, so let's go back. And let's pop that guy in. It's got an extra dot there for some reason. Okay, now find the area using the area formula. Area equals base times height. Okay, let's see if you can do that. Again, want the area of this rectangle, and let's look what we want. We want to be older than 11.6 months. Let's see if you can do that. And we know the height is 0.2564. Let's see if you can do that. I'll try and do it too in my head. And then I'll pop it in with a calculator. Okay, see what you get. I can't do 4 decimals in my head, but I can do 2. See if I have a second. So again, area is base times height, and that's the whole point. Hoping to have at least 2 people with an answer. Okay, good. 0.3590. So the way you do this, is you take the base by taking, again, oops, there we go. Take the base by taking 13 minus 11.6. So it's always the far right minus the far left of the rectangle we're looking at. It's this yellow rectangle. So the base is 13 minus 11.6. The height is that fancy number. So again, there's the height times, actually muzzle, yeah, that's fine. 11, it's actually, what was it? $13 minus 11.6. And you get 0.3590. Okay, so let's pop it in. Any questions? Any questions at all on this example? Okay, again, since these are mostly word problems, I figured I might as well actually do some word problems. I'm certainly not going to do all your homework because you only have an hour, but then you can kind of see what these look like and how you figure them out. Not sure if this is helpful or not, but I thought they do things a little differently than usual. Okay, let's go back to the next one, the next assignment. Again, this is a week with a bunch of assignments, so there we go. So let's look at operations with inequalities. And I'm going to let me see what we got here. Pick a number between 7 and 14. Pick a number between 7 and 14. Because the last ones are harder, so I want to do the harder ones instead of the easier ones. 11 sounds good. Okay, a recent study showed that 75% of all people have a commute time to work of 13 minutes or more. How do you know this was not written this month? Because nobody has a commute time anymore. We're all at home. Okay. So the margin of error is 6%. We can represent this information of this form, 0.75 plus or minus 0.06. Express this in the open interval form, for example, parenthesis 0.155, comma 8.55. Okay, so again, I want to do more than just what it asked for, because I want you to start hearing what you're going to have to know, what you're going to have to learn next quarter. This way, you know, at least when you do it again next quarter, you'll say, oh, it kind of rings a bell. Or maybe you'll remember it completely, but probably just ringing a bell. So first thing is, this is called a confidence interval when you have something like this. And the way you get a confidence interval is you take a sample, and then you use that sample, and you use the sample mean, or the sample proportion in this case, because, no, sorry, this is sample mean. Use the sample mean as your best estimate for the population mean. And that's the 0.75. Okay, so that's from the study, is the 75%. When you do a study, you don't learn about everyone in the whole country, you only learn about the people you asked. Is that clear? So 0.75 is your center of the confidence interval, or your best guess. And then the margin of error, the plus or minus 0.06, that is, well, I have this guess of 0.75, but my guess probably is not perfect. There's going to be an error to my guess. Okay, and the plus or minus 0.06 means that, well, I think that the error might be up to 0.06, probably not higher than that. Okay, in stats, we'll talk about what probably means. Okay, turns out there's some kind of 95% possibility in some interesting way, typically. So that's what this represents. Now what they want us to do is they want to say, well, if you know what the mean is, you know what that center is, and we know it's plus or minus 0.06, let's see if we can find the lower bound as for our guess and the higher bound for our estimate. So what this really just says is, to find the lower bound, just subtract. And put a parenthesis because they tell us to. And then how do we, when you subtract, what do you get? So we're going to do 0.75 minus 0.06. That one I can do in my head, but you can use a calculator. See if we get two answers or two people that agree. Good. 0.6. Okay, and again, all you do is 0.75 minus 0.06. And I'm assuming you know how to do a minus in your calculator. Then it says comma. And now we're supposed to do the plus. So if you take 0.75 plus 0.06, what do you get? See if we can get two people. Good. 0.81. Okay. Any questions on that? And notice it doesn't say invalid anymore. Okay, it's actually much happier now. Okay, any questions on this problem? And the kind of way you would state it is you would say we're 95% confident that the population commute time, mean commute time, is between 0.69 and 0.81. Okay, any questions on that? Okay, the population proportion is between 0.69 and 0.81, not mean, this is proportions. Any questions? Okay, let's take a look. Let's do another one. I'll even let you choose, pick a number that isn't 11 between 7 and 14. Okay, 9 it is. I always take the first one. Okay, you know what? This one's kind of the same. You sure you want to do this one or should we do a different one? Yeah, this one's basically the same. Let's pick one farther away. How about, let's see, we did 11. How about 13? Let me see. Yeah, this one's better. Okay. So now it says the percentage of people who have a commute time to work of 15 minutes or more, it's going to sound real similar, but actually this is pretty different, is very likely, often called 95% confident, to be between 76% and 92%. This can be written mathematically as P. P stands for the population and proportion, is between 76 and 92. Okay, or population percent in this case. Express this in the form A plus or minus B. All right, so the problem with this one is now we got to go backwards. So it's a little harder to unadd when you don't even know what you added. So this one takes some thinking. I'm going to open this one up. Any ideas on how to come up with our first number here? Yeah, the midpoint. So these 76% and 92%, those are the left and right endpoints of the interval. And the sample percent is the midpoint of the left and right endpoints. So what is the formula for the midpoint? Because we've had a section on the midpoint before. So how do you get the midpoint when you know the left and right? Any ideas? Subtract, not quite. Yeah, another word for the midpoint is the average. And the way you find the average of two numbers is you add them and you divide by 2, and there's just two numbers. So we need to add them and divide by 2. Okay. So what do you get? This one I can do in my head, but you probably can't. So what do you get? So you can use a calculator. You know, computer calculator is great for this. Okay, let's see if I have a second. Good, good. So let's do it. We have 76 and 92. So what we're going to do is we're going to put a parenthesis, 76 plus 92, and then divide by 2. So we add and we divide by 2. And it gives us 84. So that number there is 84. Any questions on that? All right, plus or minus some number. How do we get that? How do we get the number that we're adding and subtracting? And there's actually two different ways of doing it. You get the same answer. There's lots of wrong ways of doing it too, but there's two right ways. So how do we get 84? How do we get the what we're adding and subtracting? Yeah, so one way is take 92 minus 84. And the other way is to take 84 minus 76. And whichever way you do, you have to get the same answer because it's a midpoint. Okay. And again, if you take 92 minus, if you take, say, 84 minus 76, it's 8. If you take 92 minus 84, you still get 8. Any questions at all on this example? So do you agree this one's harder? You don't think so? Yeah, I think this is harder. Going backwards is harder than going forwards. Going forward, all you do is add the number and you're done. Remember that? Going backwards, you have to figure out what to do, take an average of the numbers. So I think that's a bit harder. Okay, any questions at all on this example? Okay, I want to give you a warning. Does it feel like this homework assignment is going to be harder than some of the others you've had? Yeah, there's a reason why I'm sitting here on your homework assignment, okay, where I haven't done that in the past. I want to make sure that I show you exactly what it's going to look like. Okay, and of course there's different problems, but at least you're seeing some of the more difficult ones. And that's also why I'm picking the higher ones instead of the difference of numbers. They tend to get harder as they go. Okay, so why don't I move on to the next assignment. Okay, so we just did operations with inequalities. Now it's time for order of operations and expressions and formulas. The sum sign was scary. Yeah, try not to, try not to be too afraid of it. We're going to do that, especially in the last piece. But we've already done one of them, actually, the sum. So let's do it. Okay, so here we have a choice. How about between 7 and 14? Pick a number. $12 it is. Okay, so let's see what we got. The formula for estimating the number of people N that need to be surveyed in order to have a specialized margin of error with a specified level of confidence for the average age of first kiss is given by N equals Z squared STD squared over E squared, often called sigma squared, by the way, where Z equals 1.754, depends on the level of confidence. I'm going to give you a little warning. Typically, getting that number right there is the hardest part of the whole thing. But because this is not the statistics class, you don't have to do it. But next quarter, that's going to be a tough one. And you're going to do it using pictures and diagrams and all kinds of interesting things. Okay. STD is the standard deviation. E is a margin of error. Are you starting to get familiarized with these words? You're hearing them over and over again? Like standard deviation and margin of error. They just happen. Okay. So how many people need to be surveyed if the standard deviation is 2.04 years and the margin of error is 0.152? Any questions on the question? Okay, so the first thing is what we need to do, and I think I will write something down and then put it in our, because the numbers are kind of messy. So we have 1.754 squared times STD-DEV squared over, oh, interesting. Over, so times the standard deviation, I'll tell you in a minute what's interesting, 2.04 squared over E squared. Yeah, no, this is right. It's a little different than I do it though. And E is 0.152 squared. All right, so let's write this out so we can talk about it. So it's 1.754 squared times 2.04 squared, one more time, times 2.04 squared divided by 0.152 squared. Make that bigger. Okay, so now it's time to do order of operations. What do we do first?
Multiply.
So it's the first thing we do for order of operations. Yeah, exponents come first. Okay, so we do each of these three exponents. Let's do that now. So let's go and find 1.754 squared. And let me write it out. 3 point, let's actually do it this way. I don't want to write it out. Copy paste. Copy it, pop it in here. I need to insert equation, make it a fraction. That was times. Okay, then 2.04 squared. And you get 4.1616, kind of a pretty number. Divided by 0.152 squared. And we get 0.023104. Okay, so order of operations are important. You have to do it in the right order or you'll get the wrong answer. So the first thing we do is all the squares. Then what do we do? So what's the next step? What's the next step in order of operations? Yeah, now we do the multiplication. And this is one of those where you have to be careful because it's not PEMDAS anymore, because we have that division sign. So the division is kind of like a parenthesis. It says that we're supposed to do the top, calculate it out, do the bottom, calculate that out, and then divide at the very end. So now we need this guy, just the top. Let's see if it'll let me do just the top. Nope. Okay, so I think it's that one, but let me double check. Yeah, and in 16, yep. And there's the multiplication of the top. It's getting long. And then the bottom is the same. And then finally divide. So I can just divide by what we got. And there we go. But there's a little more to it. So is the answer 554.156379224? We go back to the question. Is that the answer? I'll even pop it in and do a little copy and paste. Okay, what's wrong with that?
It's not whole number.
Yeah. Because remember, and this is important in stats, is you should always read the question. It says, how many people need to be surveyed? Well, you can't survey 554.156379224 people. But what it does say, this is the one case in math where you don't use rules of rounding. We use what's called the ceiling function. And the ceiling function says, take your number and go up to the next highest number. And that'll be 555. Any questions on this particular problem? Any questions? Okay, if there's no questions, let's try another one. Pick a number between 7 and 13 that isn't 12. Okay, 9 it is. Okay. Basketball regression line prediction. Not that there's any basketball going on. But suppose the equation for the regression line for the number of games won in season Y is given by Y equals 106 minus 0.038x, where x is the number of turnovers by the team in a season. Okay? For a team with 1,212 turnovers in a season, find the expected number of wins in a season, round to the nearest whole number. So what do you have to do? So what do we need to do? Any thoughts? Yeah, we plug in x, but x is 1212, 1,212. And not solve, plug in and do arithmetic. So we need to plug in the 1212 right in for x. Okay. Any questions on that? So what do we do? What's the first piece of arithmetic we should do here? What operation? Yeah, we first do the multiplication because multiplication comes before subtraction. So we're going to go 0.038 times 1212. And it gives you 46.056. Let's put it over here. But then we still had the 106 minus that. So now we do the subtraction. And let's go and do it. And you get 59.944. And they told us to round your answer to the nearest whole number. Okay? Because we're trying to find the, let's see, y is the number of games won by season, so you probably want a whole number. So what we get is how much? If we round to the nearest whole number. So what do we get? 60, good. So the answer is 60. Any questions at all? Any questions at all on this example? Okay, if there's no questions, let's go to the last assignment that you have to do this week. And that is using summation notation. Okay, so there's actually fewer this time. How about pick a number between 6 and 12? Okay, I saw 6 first and then 12. How's that? We're gonna do a couple. Okay. All right, we kind of just did this one actually. Not just, but our first question was this one, remember? Do you remember this formula? Y'all have it memorized? Just kidding. But do you remember seeing something that looked messy like this? So we kind of did this one, so maybe I'll jump to 12. All right, so let's read this. Okay, an online clothing retailer is exploring the best price to charge for their new designer shirts. The table below shows the price X, shirts sold, and Y, predicted sales. And the way you read that is Y hat, based on the regression line. The table below shows the data the retailer collected, and there's all this data. Okay, the sum of the squared residuals is a statistic that is important in the analysis and is given by this formula. You got a sigma I equal 1, it has an n, it has a y minus y hat squared. And the question is, find it. Okay, so what we need to do is get to understand how to read this. So first thing, you should all know how to read subtract. That's no big deal. You should all know how to read square. What's new is this baby right there. When you see this thing here, it's called capital sigma. That in words says add. Can you remember that? That's why we call it summation notation. The sum means add. Then the bottom says, what are we going to start with? And here it says we're going to start with I equals 1. That means we're going to start with the first row. And then it says I equals n. That means we're going to start, in this case, with the last row. In this case, it's I equals 1 to 5. Any questions so far? Any questions? Okay, so now we got to do this. All right, so let's go ahead and think about what we're doing. Well, what we're doing is we're adding up all these y minus y hat squareds. Okay, notice, and this is kind of important, where do you see x in this formula? Where do you see x in the formula? No, n is definitely not x. It's a trick question. The answer is there is no x in this formula. Is that clear? This formula doesn't have an x. So if you even try to use any of these x numbers, you're doing it wrong. So these numbers are irrelevant. They just don't come up at all in the formula, so don't even think about it. Got it? What does come up is the y and the y hat, and what we need to do is we need to subtract y minus y hat first. And let's do each of those. So 1262 minus 1268 is -6. So I'm just going to write these out. Start anew. So we're going to have -6, comma. Then we're going to do the next one. 1246 minus 1254. And that's -8 if you do the work on your calculator. So I'm just going to list them all out one at a time. 1270 minus 1264, that's 6. If there's anything you're not understanding, let me know. Then 1250 minus 1244, and that is equal to 6. Okay, then we have 1254 minus 1251, and that's 3. Okay, we just found the y minus y hats. So order of operations is really important. We have to do the in the parentheses first, and that's what we just did. Then we're supposed to square. So now I'm going to take all of these numbers, and I'm going to square them. Negatives don't matter when you square, so 6 squared is 36. 8 squared is 64. Then 36 again, and then 36 again, and then 3 squared is 9. Any questions? Any questions on how I got that row? Okay, now I continue on. I just did the y minus y hat squared. Now it's time to do this sigma. What does the sigma say? What does it tell you to do? I mentioned it already. Yeah, it means add. So let me just write down sigma. Means add. So now I just take 36 plus 64 plus 36 plus 36 plus 9. Any questions? Which is 181 if I did it in my head, right? But you can use your calculator. Any questions at all on this particular example? So that's a 181. Any questions? Okay, so I do want to let you know, and I want to show you something that's really important that you're not using much of, but now you might want to. And that is in the discussion forums. There's a Q&A forum. Okay, and it hasn't been used that much, but I want you to use it. So if there's any problems that you can't figure out, if there are any problems that you can't figure out, then pop it in the Q&A forum and I'll help you with it. Can I repeat what the n represents in the problem? So the n in this case, let me get back. Actually, not. The n in that case represented the number of numbers, the number of rows in this case. Okay, so it's a sample size, which is the number of rows. So we didn't really use the n, but in other situations you might use the n. But n always represents a sample size, and that's important in statistics because that's a universal letter for sample size. And in stats, it's the only thing we use that letter for as a variable is sample size. Okay, so as I mentioned, very important to pop in your questions when you have them. I'll be checking all week pretty much. Okay, there's a small chance this weekend I might go backpacking, and then of course if I'm backpacking, I'm off the grid and you can't, I won't be able to answer for a little while. But other than that, I will be checking. Okay, because it is 7:02 right now. Secret word. So what does that sigma, what does that capital sigma sign mean again?
Add.
Mm-hmm.
Oopsie doopsie.
The secret word is add. Okay, because that's what sigma means. It means add. So it's actually, the secret word is actually written twice on this page. So it's that important. Okay. So it's past 7 o'clock. I try not to go much over an hour. That's always the goal is an hour, and I made it, well, 7:02. But I will be happy to answer any questions you might have. And I'm going to stop the recording.